Okay, our number 16 was coming from the mighty topic called differential equations. Differential equations, if you want to see more, visit the playlist and then you'll see more about differential equations. There are many forms, but here they gave us one where we have a rate of change of the body temperature. So we say the rate at which a body cools is proportional to the amount by which it exceeds that of its surrounding. The body is placed in a room of temperature 25 degrees. We start with that. So we start by defining the temperature of the body. So for me, how am I going to define it? I'm going to say, let theta, my theta there, be the temperature of the body. Let theta be the temperature of the body. Now this means that what is going to change or what is varying is the temperature. So our rate is always something varying with something. So temperature is changing and also time is changing. So change in temperature over change in time. The thing is proportion, but is a proportion to the amount which it exceeds that of the surrounding. So now we have theta minus that of the surrounding is that which is in the room, which is 25 degrees. You know, because it's decreasing, the temperature of this one is going to be decreasing, it's losing temperature. We are going to replace it with a negative to remove this. So to remove a proportionality sign, we remove it by replacing it with a negative proportionality constant. We are putting a negative because the rate is decreasing. So now we separate variables. If you want to see more about separating variables, visit the playlist. Equals to now negative k dt. You take this down, then you take this to the other side, and then thereafter you have to integrate. From here you see that we get natural log of theta minus 25 equals to negative k t plus, some people put c, but natural log of c is better. Take this side, you have natural log of theta minus 25 minus natural log of c equals to negative kt. I always want to simplify my is in that form. So that we have now natural log of theta over c equals to negative kt. Then we use the property that natural log of a equals to b. This one becomes a equals to e power b. That's the property I'm going to use there. Of course, this one log to base e. That's what we are having. So now we start. Now I'm going to have now theta minus 25 over c equals to e negative kt, of which my theta minus 25 equals to c e negative kt. You can easily simplify it that way, or you can leave it here. But for me, I prefer that one. So we're telling us that after 6 minutes, the temperature of the body dropped from 90 to 60. Meaning before 6 minutes, when T is 0, the temperature dropped from, so meaning the temperature of that body was 90 degrees Celsius. So putting here, now I have 90 minus 25 equals to C, E now negative K into 0. So you can every start my C is 65. Substituting back there, have now my theta minus 25 equals to 65E negative KT. Now remaining with get the value of K. By the time they told me that after 6 minutes, temperature of the body was 60 degrees. Put here, so from 60, 25 equals to 65, E negative K, now times our 6. So that this one is giving me 35 divided by 65 equals to E negative 6 K. Making it the subject, I'll be having 35 over 6 power 5. Now I multiply by 1 over 6, both sides, to have that, which you can every see. This one becomes now all of my EA from here. I'm going to substitute it from there. So I had now theta minus 25 equals to 65 e power negative k t. The all of it I'm going to substitute it there. So that my theta minus 25 is going to be 65. Now this one is going to be 35 over 65 power 1 over which is 6. When you multiply this t times this, you get to that. So now they're telling us that find the time it takes the body to cool from 40 to 30. So meaning I have to first get the theta when it's 40 degrees. I want to get the time. And put here 40. I have now my theta is 40. I'll be having, I think, 15 equals to 65 into 35 over 65 t over 6. Introducing natural log of both sides after dividing, I have natural log of 15 over 65 equals to t over 6, natural log of 35 over 65. And then here I get my t as, press your calculator properly. There I will be having now natural log so here I'm having my answer as I have my answer as 14.1238 minutes. And I come when my theta is 30 degrees. I have now, when I put here theta is 30 degrees, I have now 5 equals to 65 into 35 over 65 t over 6. To this natural log, so I have now natural log of 5 over 65 equal to 2 over 6, natural log of 35 over 65. So my t here, I'm getting it as have it as 24.8606 minutes. So now they want me to get the from that to that. So now my time is going to be now, I get 24.8606 minus 14.1238. So my time now there becomes I get 10.7368. So my time, which I can approximate the next minute, which is 11 minutes. So that means that my body to cool from 40 degrees to 30 degrees, I need only 11 minutes. So that's how that rate was supposed to be done. I wish you well. If you want to see the details, you can visit the playlist.